Alright, today we're going to be looking at net change and how that relates to integrals and the fundamental theorem of calculus and everything like that. So, first let's remind ourselves of what the fundamental theorem of calculus is. If little f is continuous and if big F is the antiderivative of little f, then the integral from a to b of f of x dx is big F of b minus big F of a. So we've been treating this like the area under the curve for the most part. But I want us to think of this as, again, the rate of change, because f is the derivative of big F. And so this is the rate of change from a to b. And remember this s, this integral sign is an s. So we're adding up the rate of change from a to b. Okay? So if we think of that, that might help us understand net change. Because net change, all it does is it adds f of a to the other side. So we say f of b equals f of a plus the integral from a to b of f of x dx. So what this is saying is we've got a starting point, f of a. So this is some known point or value or quantity. So we know something about it. Well, if we know this and we know the sum of the changes or the net change, well, then we can go from A to B. If we know this, we know the change, we add those together, we get to f of b. Now, usually these are approximations. Usually the functions are models of data that we've gotten, and we just use some known starting point and predict values from there. So let's look at this. Let f of x be an antiderivative of x over x cubed plus 1 if f of sub 0 equals 2, f sub 0. F of 0 equals 2, find f of 3. Okay, so we're looking for f of 3. We know f of 0, so we need to change from 0 to 3. And then our rate of change is x over x cubed plus 1. So if we look at this, we can't actually integrate this by hand. No u substitution or anything is going to work out for us. We might be able to do a technique later on called partial fractions, but we'd have to really look at that. But we know we can use our calculators to get an approximation, which is exactly what we'll do. So we know we start at a value of 2, and we're going to add the approximation for this, which comes out to be 0.879. So f of 3 is approximately 2.879. Pretty straightforward. Doing the same thing down here. Here's our rate of change. We know the value at 1 is 3, and we want to estimate the value at 5. So f of 5 equals f of 1 plus the change from 1 to 5 of the square root of 4x squared plus 5 dx. So f of 5, this is 3 plus, do this on the calculator, 25.866 gives us 28.866. Do it one more time. Here's our rate of change. Here's our known value. So we start at -2. No, that's what we're trying to find. Sorry. And we start at -1. We add the change from -1 to -2 of our rate of change, which is e to the x squared dx. So 2 plus, that turns out to be negative 14.990 gives us a value of negative 12.990. So that's one way we can look at net change. Pretty academic way. I'm going to turn this page and it's going to look pretty scary. We look at this and we've got this nice big long word problem. I'm going to let you read it on your own So you can pause now and read it. I'm just going to hit the highlights. This is the rate of change of the entering population. So this is the number of people that are entering per hour. Okay, L is the number of people leaving per hour. So we have entering and leaving. The function is valid from, those are models. The function is valid from 9 to 23. So that opens at 9 a.m. and closes at 11 p.m. Then we get into our questions. Well, and the other important part is at 9 there are no people in the park, so they didn't let anybody in early. So we get to our questions. A. How many people have entered the park by 5 p.m.? That is when t equals 17. Round your answer to the nearest whole number. Well, entering people is e, so we're going to integrate from 9 to 17 of the function e of t. So this is the rate people are entering. We're going to multiply by the number of hours from 9 to 17. And we get 600 or 6,004 people. This is before 5 p.m. B. The price of admission to the park is $15 until 5 p.m. After 5 p.m., the admission is $11. How many dollars are collected from admission to the park on a given day? Round your answer to the nearest whole number. Now again, these are approximations using these models. So we're looking for before 5 and after 5. Before 5, we had 6,004 people at $15. That comes out to be $90,060. After 5, we need to figure that out. So that's going to be from 17, that's 5 o'clock, until close, which is 11 of the number of people that entered the park. That comes out to be 1,271 people after 5 p.m. So 1,271. That's $11 a person. That comes out to be 13,981. And so the total money earned is 90,060 plus 13,981 for a total of $104,041. Oops. Sorry, I didn't mean to do that off screen. Take a second to write that down. And then we'll look at the last part here, part C. Scroll back up here. Let h equal the integral from 9 to t of the e function minus the L function. So this is the number of people entering minus the people leaving. And that's the rate of change there. From when we open to when we close, or any time in between. The value of h of 17 to the nearest whole number is 3,725. Find the value of h prime of 17 and explain the meaning of h of 17 and h prime of 17 in the context of the amusement park. Okay, well, let's rewrite this so we can see it down here. H of t is the integral from 9 to t of e of t, or e of x, minus L of x dx, because you got to be a different variable on the inside there. Well, let's take the derivative. When we take the derivative, we're going to use the second part of the fundamental theorem, and we're just going to take the top expression, which is just t, and stick it in there for our variables. It's just going to be e of t minus L of t. So h prime of 17 is e of 17 minus L of 17, which, using our calculators, we get 380 minus 761. So h prime of 17 is negative 381 people per hour. H of 17 is 3,000. They gave this in the problem. 3,725 people. So what does that mean in context of the park? Well, this is the rate of change. So h prime is just the rate of change. So this is how many people are coming or going at 17. So t equals 17 is 5 o'clock p.m. So at 5 p.m., more people are leaving than entering. So we have about 400 people leaving. But h of 17, this is how many people are in the park. People in park. So we have almost 4,000 people in the park and only 400 leaving. So we're in pretty good shape.